have a space. Okay, this charged arc, it will subtend an angle alpha. Let the linear charge density be lambda. Let R be the radius. You have to find out the field strength at the origin. So this is a charged arc. Find E bar at origin due to charged arc. And what is that arc? Arc will subtend an angle alpha at the origin, and let R be the radius, and let lambda be the linear charge density. What can be the? We don't have any formula, no? So what shall we do? Again, we are going to assume an element. Then due to that small element at origin, first we'll assume a small element. Then due to small element at origin, what is the electric field? Then I'll integrate. I'll make it this small, then the diagram, I'll bring another diagram. Yeah. Now this is what. Let me define. These are the boundaries. Let me assume a small elemental I'm going to assume two symmetric elements. And now the question you have to ask, like, sir, why you are bringing two elements? Because previous problems we did with one element. Previous problems, it was only one element. Now I'll bring two elements. So like that, you look at the, when you are finding out the gravitational field or electric field, so what we do is like we'll define the elements, sometimes one element, sometimes two element. So what is the method like when I should assume one element, when I should assume two elements? I think this is a primary doubt will come for a student. So this will be dE dash, dE dash, this is dQ, this is dQ. So this angle, let it be theta, theta, d theta. This angle will be theta, theta. Why I took two elements? In case of rod, we took one element, no? So what is the method like when to assume two elements, when to assume one element? If you are finding out the field about a point where the charge is distributed symmetrically, you see that one. About origin, I'm finding out field. How much of charge, how the charge distributed, it distributed symmetrically about y-axis. So therefore, I'll assume two elements. Why here only one element? Because the charge is not distributed symmetrically about point P. Just it is above this line. This assumption is very important. Please do learn. Such skills only will help you a lot. So why you didn't assume two elements? It's not distributed symmetrically. If you assume one more element here, what you get? You'll get dE double dash. You do it, then also you will get one x and y component. So y to double again two elements. Let there be only one element. able to get this one. If this point lies on a bisector, then I'll go for two elements. For a finite rod, if I ask you to find out the field strength on the bisector, then it's better to assume two elements, because the reason for that, about this point, the charge is distributed symmetrically. Getting the idea? So these are some mathematical things which you should learn here. When to assume one element, when to assume two elements. Because about this point now, about the bisector, the charge is distributed symmetrically. That's why I'll go for two elements. The charge is not distributed symmetrically with respect to this. So therefore, only one element. Then I think same thing with this semi-infinite. Here also the same condition. Now, the charge is distributed symmetrically about y-axis. So therefore, two elements will come. So due to an element is dE dash, due to this element will be dE dash. Okay, let's get into the mathematics of this one. So first we'll define what is dE dash is equal to K dq by r square, where r is the radius. Okay, dq will be lambda into ds. What is ds? R d theta, angle subtended by the arc. So one r get cancelled. So k lambda r ds will be yeah, fine. This will be d theta. No, what is the resultant field? The resultant field should be equal to 2 dE dash cos theta. 2 dE dash is what? K lambda r cos theta d theta. What should be the limit? Anybody limit? What is the angle subtended by the arc? Alpha. Shall I write 0 to alpha or 0 to alpha by 2?
0 to alpha by 2.
0 to alpha by 2, because I assumed two elements. If I assumed only one element, 0 to alpha. I assumed two elements. So now what will happen? 0 to alpha by 2. What is this angle? 0 to alpha. This is the theta equal to 0 degree line. So 0 to alpha by 2. The limit should be 0 to alpha by 2. So therefore this will become.
Sir, if we assume that a single element, we can take the limits from minus alpha by 2 to plus alpha by 2, sir.
Single element, if you assume, you'll die with mathematics. Not advisable. Huh?
Yes, sir.
Then if you take single element, then 0 to alpha, you should write it. But again, cancelling the components all will be a big headache, no? Cos theta will become sin theta. So the field strength at O, let me write, because at point O we are finding out. At origin, it will be 2k lambda r sin alpha by 2. I suggest you to remember this, or lambda is it a line charge? Is this a line charge? Yes, it's a line charge. Same rod only I bent it. Please have general thing. You purchase, you can have some wire. I think some iron wires which are used to bind some rods in construction. You just go to any hardware shop. You ask them to the like a 1 millimeter gauge iron wire. They'll give that one, which is used in construction. Not thick rod, just thin rod. Okay, that particular rod will be like a bundle will be there. You can bend it in any shape. No? So if it is a long finite rod, if the straight finite rod, if you bend it, it will become arc. You can make it semicircle, ring, quarter circle. So what is lambda by 2 pi epsilon naught r? Due to line charge. Due to arc, what happens? Sine of half of the angle subtended. For exam, you have to remember, this will be a lot of confusion. This will be much easier. So the field due to arc is field due to line charge lambda by 2 pi epsilon naught. And this is due to long rod into sine of half of the angle subtended by the arc, where at the center of the arc.